dozen ways of graphing that equation. We are graphing inequalities. For now, just say it's y equals x squared plus 3x minus 4. Don't be concerned about the inequality symbol until it's actually time to start graphing. So just treat it as equal. And you've been asked to graph these things for over 2 weeks on a fairly regular basis. Anybody got a suggestion? Factoring is a good start. Plus 1, x minus 4. That creates a negative 4x. That creates an out. You need minus plus, don't you? So you can guess and check, kids. So it factors is x minus 1 times x plus 4. And I'm going to rewrite that just so it's clear, because I'm using pen and I can't erase pen. That's how it factors. Why would you factor that? You have x-intercepts. Where are they? They're at 1 and negative 4. I'm going to make a little table. I know something you don't. That's why I gave some space in between the 1 and the negative 4. But those two x-intercepts happened when y was what? 0. Yeah, and you can see that up, well, I guess you can't see it up here, but that's the idea. X-intercepts happen when y is 0. So I got two pairs, two order pairs. Now, what's something that you more or less have to graph a quadratic? You have to have a vertex. That's why I left that space in the middle, because it is in the middle. There's two ways of getting the vertex out of this one.
You have methods, yeah, you have them backwards on a graph.
I do, don't I?
Yeah.
Crap.
Oh. I was about to point it out.
I'm glad you did.
Oh, I messed up. Sounds like that.
No. Have you not been in here? That should be right. There's two ways. We need that vertex. That's your most important thing. And there's two ways of doing this. Your form quiz, you had to remember, you're supposed to memorize where the vertex is at p plus q over 2. You're supposed to memorize that. It's on your formula quiz. But that thing was given to you in standard form. How else could you get the vertex? Also on your formula quiz. Quadratic formula returns 0, son. It returns x-intercepts. I'm going to use that x coordinate of the vertex is at opposite b over twice a. Where it is. Opposite of a positive 3 is a negative 3. Twice a, which is what? 1? Negative 3/2. There's the x value vertex. I'm not asking you guys to plug fractions in. 4 years ago I would have. This year, no. Take a negative 3/2, store it where? Store it to x. Type the original equation in. And you get negative 6 1/4. I didn't do anything special there, kids. I didn't square any numbers in my head. Just typed it in. Now you got 3 points you can plot. I already plotted 2 of them. Negative 3/2 is negative 1.5, and then down a little more than 6. Now, don't start drawing yet.
Negative 1.5 down to 2.
Back a unit and a half, down 6 1/4. Time to focus on this. Y greater than. Solid or dashed?
Salt dash.
Dashed. How do you shade? Shade above. You're still stuck in 8th grade where it was either left or right. It's a combination of all three ideas here. So it's dashed. And, you know, some kids think like shading spots like this is shading above. It's not. We have to be above the dashed line. So where do we actually have to be? We have to be inside. All right. That's out of the way. Y'all can go to lunch. Yeah. There are two ways of doing this problem right here. And I'm going to let you guys decide what you want to do. So you guys tell me what to do. Can't factor it yet, Devin. Okay, so you want to go this route. Okay. There's another route that doesn't involve factoring, but we'll go this route. X squared plus 6x minus 7 greater than or equal to 0. Of course you can do that. Factors is x plus 7 and x minus 1. Now, let's make a little table here. Where are your x-intercepts at? X equals -7, x equals 1. Let's just change sign and be done with it. That happened when y was what? 0. Do you see that there's a 0 where y usually is, kids? 0 and 0. So back 7, 3, 4, 5, 6, 7. I think that's right. To the right one. Now, these numbers are actually pretty nice. You don't actually have to use a formula. Isn't a vertex in the middle? What's in the middle of -7 and 1? What was that? -3 is in the middle. But if you need a formula, again, you can go right back up here and you can do that x is opposite 6 over twice a 1. What do you get? You still get -3. Either way, you get it. All right, so we have our x value. How do we get our y value? There is no fractions on this thing. Do you see fractions? It's like plug it in. There are no fractions. I don't know why you're saying that. I can tell. I'm just typing that -3 into the equation we wrote. -16. I don't know if your grid goes that far down. Your grid goes to 3, 6, 9, 12. Your grid goes down to 14. So I'll just have to drop a little bit down lower than that. It's -3, -16. All right, talk about shading. Solid or dashed?
Solid.
Solid. That is a, now, here's kind of the thing here. Let's rewrite this. Put a y there where that 0 is. Might make it more obvious to you. I don't know. We're going to shade above or below? Below, because it's saying y is less, right? Now, I'm actually going to stop right here. Maybe I shouldn't have done this. Sometimes I do things I don't mean to confuse you, but it might. What's it actually say that that's completely wrong. See, that's why I shouldn't have done that. Should not have done that. Erase all those marks.
Everything?
Leave the graph. Leave the graph, but erase the shading around it. You guys took a different route than kids usually take, so we're doing a little bit different. The equation you had was x squared plus 6x minus 7 greater than or equal to 0, and that actually needs to be stopped. That needs to be thought of right there. What this is asking where is the graph above 0? Where is the graph above 0? That happens here, and that happens here. That's where the graph is above or equal to what? 0. That's where that's happening. So that actually happens for values of x when we're less than, I think it was -7. For all x values less than or equal to -7, because does this graph keep moving forever to the left?
Yeah.
It happens for all values of x when the graph is where? When x is greater than or equal to 1. That's the tricky part about it. You're writing inequalities to answer this thing. That is kind of the tricky part. And if you thought about the shading here being greater than or equal to 0, it'd be all this solution space over here and all this solution space over there, because that's where you're above 0.
So if we have had the greater than or whatever it is, 0, it's always going to be like above 0.
Above 0. So it's kind of funky looking. We're going to talk about on the next example how to write that as an interval as well. As the next example, there's no math you do. You're just kind of looking at a graph to try and reinforce how you're supposed to answer these questions. So the graph of function is shown. Use the graph to determine the following. Now, f of x is fancy for what? This is saying where y is greater than 0. And you answer it. If I can find a pen that'll write. That one works. You answer in terms of x. What x values make this true? Maybe I should buy some colored pencils. Just make things easier. Is the graph greater than 0 here and here?
Yeah.
That is where the graph is above 0. You have to answer this a lot like the one we just answered. What values of x make this piece true? What about -2?
Equals 0.
If it's greater than -2, I'd be talking about stuff over here. This graph runs to the left forever. Less than. X is less than -2. As long as x is less than -2, this graph stays above 0. But if x was something like 0, is the graph above 0? Graph's down here. The other place this happens is over here. Or when x is greater than 4. And I realize that kids struggle with this, and I've watched videos. I don't know how else to explain it other than what we're showing you visually. It's where the graph is above or below 0. You just kind of have to see it. Now, does anybody know how to write that as an interval? Interval. I agree with that. Parentheses. That handles this piece. How about this piece on? No bracket. Or infinity. And there's a u in between them. Union with. Example B is about being less than 0. That's this entire region right here. What x values contain that region? Negative 2 less than x less than 4. It says x is trapped between negative 2 and 4. As long as x is between those 2 points, the graph is below 0. That one's easy to write as an interval. You need to be getting interval notation down if you're college bound. You do. What's the difference between B and C? Symbol. I don't use less than symbols, I use what? Yeah. So it's going to look just like this, except the symbolism has a bar under it. So x is less than or equal to negative 2, or x is greater than or equal to 4. What's that look like as an interval? Oh, that's the wrong spot for that, isn't it? I said B and C, and what did I do? Didn't I write down A? Negative 2 less than or equal to x less than or equal to 4. What's that look like as an interval? Wasn't so bad. Are A and D more or less alike? There's difference in symbolism, kids. That's all. So the same thing, except we're using less than equal, greater than equal. And on the negative 2 and 4, what do we use? Brackets. So negative 2 less than or equal to, sorry, I wrote that backwards. X is less than or equal to negative 2, or x is greater than or equal to 4. As an interval, negative infinity to negative 2 with a bracket, union with bracket 4 to infinity. Interval notation was actually one of the better things y'all did on your last test, although I guess that was a week ago. Probably already gone. Means you learned just enough trying to make it through a test. That's what that means. It's always notation. All right. There's some of that stuff in your homework, kids. We can go over it in your homework tomorrow. Next example is solving something algebraically. And I've got little steps off there. It says get in the standard form, find critical values. We don't call them solutions anymore. We call them critical values by factoring or using the quadratic formula. Your notes are all set up to factor because I don't want to spend time on quadratic formula in class. 3, visualize the solutions on a number line. 4, test values your number line suggest should work. And 5, throw out any extraneous solutions. Write your solution space, preferably as an interval. So we'll kind of walk through you on that, what it means. First off, where's that 4 belong? Left. 2x squared minus 7x minus 4 greater than nothing. Kind of like we did the first one. Does that factor? Yes. I just told you, your notes are designed to factor. What's it take to create a 2x squared? It takes a 2x and an x. Need factors of 4, rearrange that when you are done, you get a negative 7.
X is not minus 4.
That's a 2x, Garrett. That's an x, because 2x times x is 2x squared.
Yeah, it's the parentheses. They look like X's when they go for the plus 1 minus 4.
Plus 1 minus 4 works. Negative 8x on the outside, positive x on the inside, sum is negative 7. And a positive 1 times a negative 4 creates a negative 4. Still greater than 0. Now, this guy right now should be ignored. Because what we're about to write down wouldn't make any sense. We're about to write down that x is greater than a negative 1/2 if we do the math, right? Subtract 1 divided by 2. Or x is greater than 4. That doesn't make sense. That is saying that we would start here and we continue right and pass through the 4. One of those is probably right, one of them is probably wrong. That's why I'm saying that we call these critical values. These are critical values. We plot them on a number line, kids. Open dot too on these. Why open dot? Symbolism up here. Doesn't have a bar under it. It ain't solid. So there's 4 and there's negative 1/2. Now I talk about testing around. See, the answer to this could be left of negative 1/2. It could be between negative 1/2 and 4, or it could be past 4 on the right, because these are inequality answers. They're not just one specific answer. They're inequalities with vast ranges of choices. So we have to test around these things. What we do is we test to the left, we test in the middle, and we test to the right. And you just got to make up a number. When I talk about testing to the left, I'm talking about something less than negative 1/2. Yeah, I would test negative 1. You do that by letting x be negative 1. What's something in between negative 1/2 and 4? 0. If 0 is an option, you use 0. I'm going to test 0. I'm going to let x equal 0. Then we're going to test to the right. What's something to the right of 4? 5. I'm going to let x equal 5. And I'm not going to use the equation we wrote. I'm going to go up here. And I'm not going to show all the steps. You know, one of the ways you'll do this is by playing along instead of just, copying my stuff. So I want to test a negative 1. I'm going to take a negative 1. I'm going to store it to x. And what I'm going to do is I'm going to type it in the right-hand side of that original equation. Just the right-hand side. It's 2x squared minus 7x. And my calculator said 9. Is 9 greater than 4? That's true. What's that mean? That means that everything to the left of negative 1/2 is a valid answer. That is telling me right there that x is less than negative 1/2. Yeah. Sometimes. Sometimes you'll find ones that all 3 pieces match. It does happen. By the way, this is like one of those really, really bad things in Algebra 2 where nobody ever does what I tell you to do. You try and come up with your own little stuff. You try and look for shortcuts about which inequality symbol to flip. It never works. It hasn't worked in 10 years. It ain't going to work this year. Do it my way, kids. You can go on any textbook and look how it's taught. You can look up any video and look how it's taught. This is how it's taught. If you watch The Mandalorian, this is the way. Any of you actually watched The Mandalorian? One kid got that. How sad. This is the way. What's something in between that negative 1/2 and 4? So, go to my trusty TI, store 0 into x, and second enter twice. I got 0. So there's a 0 here. Is 0 greater than 4? Failed. None of this crap matters. The answer ain't in there. Then I take a 5, store it to x. You know, I keep telling you kids, if you'll play along, you'll retain this stuff a lot better. It's like playing a video game about football and expecting you can actually play football. Is 15 greater than 4? True statement. It's everything over there. Now, as an inequality, what is this part of the number line telling us? It's telling us x is greater than 4. And there's actually the word or in here. Interval time. If you're less than a negative 1/2 forever, where are you? Am I allowed to be either one of those two values? No. The word or interval form is the letter U, unioned with. 4 to what? Infinity. That's how you do them algebraically. Watch, read the steps, kids. Do them in order. Don't pick and choose either. All right, man. What time is it? Get a calculator and turn it on. Let's see how far we can get. I'm going to do part A for you. You can read the text. You can try and figure it out. But you've been asked to do that on a couple of quizzes and tests in a row. Plug in numbers into a standard form for rocket problems. Part A says find the maximum height, and I'm trying to get you to use a calculator here. This may not have been the best example for this. But go to y equals, done by pressing y equals, and then type that equation in. Now you don't have a t button, you have an x squared, an x button. And there is a difference between the minus button and the subtraction button, so make sure you're using the right signs here. Plus 20. You should have that in y1. Again, we pressed y equals, we type the equation in. Now, your calculator is going to give us a graph if we tell it what to do. You're going to have to pay attention to this. Always in here, do a zoom, hit the zoom button. 6, standard zoom. Don't just hit graph. You don't know where your calculator's been, you don't know who's had it. So you kind of reset it at defaults. And you don't see anything when you do that, because a standard window goes up 10, down 10, left 10, right 10. This thing's up there somewhere. It crosses the y-axis at 20. And then it goes up. There's a window button here. Now, this is kind of guessing. Where do you think it does what? We're going to look up 1,000 feet by changing the y-max to 1,000. So I hit window, and I went down to y-max. I changed it to 1,000. Now I'm going to hit the graph button. Looks like it kept going, doesn't it?
That's the rocket.
That's the rocket. They go up. I'm going to change that to 2,000 because maybe that's about halfway up. So I went back to window, y-max, 2,000. Still going up.
Oh, it's starting to come back now.
I don't think so.
Oh, it's starting to curve.
Starting to curve pretty good. Went to 6.
Yeah, it goes up a little bit and goes.
Oh, that's plenty of room to play with. Now, does it look like it's going to start coming back down?
Yep.
Which direction do you look? To the right. Let's change that X max to about 40 just to be on the safe side. So I changed X max to 40, Y max 6,000. Did I know the numbers off the top of my head?
No.
No, I guessed and checked. There is that equation, model, and graph. Now, it says find the maximum height of the rocket. Does that happen right there?
Yes.
All right. If you read the instructions, it says something about second calc. Calc is right there by the trace button in blue. So second trace. Do you think that is a maximum?
Yes.
Of all the descriptors in here, that point up there is a maximum. So you choose maximum when you press enter. Now, it's going to ask you for two things. It's going to ask you for a left bound and a right bound. Left bound means get to the left of where you think the top is. And it doesn't have to look exactly like mine. You just have to be to the left of the vertex and press enter. Right bound means get to the right. So you get to the right and you press enter. And the third one's for a guess. And you just press enter for a guess. There's the maximum height. Is it the x value or the y value? The y value. X is not height, son. X runs left, right. Y runs up, down. So your height is at 3,926.25 feet. Pretty good for a model rocket. Over what interval of time will the rocket be at least 200 feet in the air? Well, what you do is you put a 200 in there for height. NY2. Who said that? So you actually did some of this?
Right, it has the directions.
Oh. And I guess that's where we stop. Anyways, you got your homework, don't you?
Yes, sir.
We'll figure anything else out about it tomorrow. Enjoy your day.